Oop, I think it's sharing the wrong screen here. Let me take 1 second just to move it over to the other one. Okay. Hello, everyone. My name is Andrew Leedy. Let me switch the screen.
So I took everything out in Illustrate, and then I brought it in as a separate model, container.
All right, can you see my screen?
Yes, sir.
Okay, sorry about that. Okay, hello everyone. My name is Andrew Leedy. I am an application engineer here at PTC, and I am the one who's going to be doing the quick run through of the Simulation Live extension. So Simulation Live brings real-time simulation capabilities directly into our CAD environment. So we're integrating ANSYS's best-in-class simulation capabilities directly into Creo to allow engineers to really just rapidly explore and instantly understand the impact of any of the design changes that they're making as they go through that design process. Now, before I get into the actual demonstration, I usually like to just take a step back and talk about some of the challenges that we're hearing from some of our customers and that you might be running into as well when it comes to the problems integrating simulation into our design process. One of those problems is that analysis is just too time-consuming in the early stages. You know, as our models are in a constant state of change, it's something that we don't really want to have to worry about. So typically an engineer is just relying on their experience and their intuition when they're making any of those critical design decisions. And the analysis is seen as something that we'll just do after the fact, maybe as a validation sort of check on the model. There's limited support for analysis-led design and optimization. You know, analysis is seen as something that maybe only the expert can do or that we have to do in the late stages just because those models are in a constant state of change and it's too cumbersome to have to go back and forth between the analysis and the engineer to determine what's the best route forward. How do I get the best design out? So again, it's typically just seen as a checkbox. Does this design work? Yes or no, and then go from there. And if we're not running analysis, many times we're relying on late-stage physical prototyping and testing. You know, if you're not relying on doing this with a computer, then you have to build a prototype to make sure that the design actually works. And these prototypes are going to be needed to validate the performance of that design. But there is just a real disconnect between the actual design and the analysis at that point then. And especially if you have to go back and start reiterating on top of those different prototypes, how many do you need to actually be able to determine if this is the best version of the product that you can push out? So some of those challenges that we talked about, the solution that PTC came up with was this Creo Simulation Live. So again, what that is real-time simulation capabilities in a CAD environment. We worked directly with our partner ANSYS to be able to integrate some of their technology into Creo Parametric to be able to kind of bridge that gap between the analysis world and the computer-aided design world. So the whole goal there is to remove that barrier between the CAD and the CAE world, basically working in that unified modeling and simulation environment. It's designed to be easy to use. It's more targeted towards an actual engineer or a designer, not targeted towards that high-end analyst that's doing this every single day. It's geared towards the person who's just within Creo Parametric and wants to be able to get some get some idea of, okay, what if I add this hole? What's it going to do to my model? What if I move this feature to this location? How is that going to change my analysis? And be able to get that feedback very easy. It also works with the common data model. So we're working directly on top of our Creo Parametric design model. It's just opening up basically another tab to be able to set the simulation up, and then it works directly alongside our actual design environment. So we're not going into a separate sort of program or sending this off as an export in a different file type. We're working directly within the environment that the engineer is used to. The extension is designed with the designer in mind and not the analyst. So it's consistent with the rest of our Creo user interface. It's easy to set up loads and constraints, especially if someone's familiar with our Creo Simulate module. It's very similar to that in the aspects of how you actually apply this and kind of the user interface that you go through to be able to do that. This does bring that single unified environment for our design and analysis. So if anyone is familiar with ANSYS Discovery Live Simulation, so that was something that ANSYS came out with a little while ago. We basically embedded that technology directly into Creo Parametric, allowing us to see any changes to our simulation as we update our parametric model, whether this is going to be through a dimension change, a direct modeling capabilities, if we're taking this approach more as a, I just want to see what happens when I move this wall out a little bit. Whatever design capabilities we're working with within Creo Parametric, we can run that directly alongside our simulation. There's multiple different types of analysis that we can run and that are supported as well. So it supports linear, structural, thermal, and modal analysis. And the analysis is going to change based off of anything that we might do just beyond like a feature change. If we change the materials out, we can always go back and change our analysis around, add different constraints in, change the different loads that we're applying. Basically, it allows us to just play around with multiple different what-if scenarios and be able to explore those very rapidly and very quickly. Now, this is new technology. The solver engine is using the GPU rather than the CPU. So what this means is that we can get our analysis a lot faster, which you'll see during the demonstration. It's basically instantaneous. As soon as you make any kind of change to the model, it updates the graphic that's driving our simulation here on the screen. Now, this does require a special NVIDIA graphics card. So I have a slide at the end of the demonstration which will highlight those what the requirement is in that regards. But once you have that support graphics card, basically that's the only requirement for the actual extension here. So now I do have a quick demonstration I can go through to show what this would actually look like played out here. So for this demonstration, we're going to be looking at this guitar effects pedal. So for anyone who is unfamiliar with what this actually does, basically a musician can step on this to alter the sound that's going to come out of their guitar. So traditionally, since this is going to be something that's going to be stepped on and it has to withstand the stomping that a musician is going to have to do throughout their whole set, this is something that might be made out of something like bent sheet metal. But I want to go through and explore an alternative design, maybe make this out of ABS, maybe we're going to 3D print this in plastic, or maybe it's just going to be cheaper to make this in plastic. But it's important that this still holds up to the actual structural impact that we're going to put this under, as it's going through its actual life cycle here. So I'm concerned with the force that someone's going to be stepping on this, and then it's going to compromise the housing and maybe snap this in half. So traditionally, I might pass this over to an analyst to analyze it for me, or I might not even run a simulation at all. Maybe this is just something that I just over-engineer to make sure that it's that it's going to withstand the environment it's in. But that means that there's going to be extra cost because we're making a product that is not built for the actual application. It's built beyond the application that we're using this for. So instead of doing that, we're going to be using Simulation Live here. So it's basically just another tab on our user interface here in Creo. We just ran up to our ribbon at the top. We just chose Live Simulate from there. And now we're going through the actual setups from this. This is where I access the Simulate Live functionality. So select on that tab, basically just changes the ribbon around to reflect that now we're more in that simulation mode. So we just choose which type of simulation we want to run. So it's going to be structural, thermal, or modal. Then we go through and do the setup. So set up our constraints, apply any types of loads, and we have multiple different types of loads and constraint types to display. In this case, we're just going to be placing a simple force down on the top of this. We're just going to constrain it with a fixed constraint, a very simplified approach to this particular problem. And then we're going to run the simulation from here. So as soon as we click that Start Simulation button, basically the results are going to be immediately displayed on the screen here. And it's going to display all the results, not just what I'm initially stuck with. So initially we had ran this as a deformation test. If I go into and check out my von Mises stress, it's just going to update the graphics on the model, change around that legend over there in the top right to reflect that now we're looking at von Mises stress. But otherwise, it's pretty instantaneous how fast we can actually get to the simulation results from here. So now the real strength of this particular extension isn't just to be able to pull up a simulation very quickly without having to wait a few minutes to actually see the results. It's that I can make live updates to this model at any point during the simulation. So the simulation is kind of just running, in the background. It's just a graphic on the screen at this point. But I can go through back over to the model tab within Creo and just start to make some changes onto this. And something that's really easy to do, we just put in a user-defined feature. It's already fleshed out. So we don't have to worry about building, multiple different extrudes and going into a sketch to build this. But basically, as soon as I put in a new feature, it's going to update the actual simulation that we have there. So you can see as we go through and mirror this as well, adding in another mirror feature, it's going to start to update the simulation. It also updates over there on the right, we can see the different von Mises stresses that were applied. You can see some new stress concentrators that were added with adding in those features. But this allows me as the designer to get a real understanding of all the impacts that the design work that I'm doing is actually making to that simulation model. So anytime I make any kind of model change, whether there's going to be a dimension or a new feature or removing a feature, I can see those changes displayed right in front of me. And at any point, it's just a quick tab up there in my quick bar. If I want to go back and see what the deformation looks like and see if it has changed from where we were before, I can just instantly just toggle back to that. Now, in addition to making model changes, we can also at any point go back and change our actual simulation. So maybe we want to add in some extra constraints here, some fixed constraints to the bottom of those user-defined features we placed in. And as soon as we update the constraints, it's going to start to modify the actual simulation that we have. So any changes we make onto the model, whether it's going to be on the simulation side or on the parametric side, we can see any of the design implications. And you can see our stress has moved up to where those user-defined features are, but we've drastically reduced that stress on that top face that we were looking at before. Now, as I said, you know, it's not just restricted to new features. If we want to go back and modify one of those features, so here we have a datum point that was controlling where that was actually placed. If we change the dimensions around, it's just going to update our simulation once again, and we can toggle back to the deformation, see if this is more suitable to the use case or if we need to make some further changes onto this. So it's all about making those changes, then interpreting the results. So see if that deformation is acceptable, see if the von Mises stress is going to be acceptable. Allow me to explore all the different what-if scenarios that come with the changes that I would make to try to reduce those certain parameters. The best part about this extension is that any engineer can really use this to get a better idea of the performance of this part. I wasn't doing some crazy high-end type of analysis that only an expert is going to understand how they were supposed to set that up and run. That was just a very simple, first stab at this problem early in the design phase to see if I'm making smart decisions as a designer as I'm going through and modeling this. So just to wrap up what we saw there, so basically what we're talking about from this extension is just bringing, bridging the gap between the simulation world and that computer-aided design world. Allow the engineers to perform analysis early and often. Don't have the simulation and the analysis and the design be separate realms. Put them together so that I get a really good impact, even at those very beginning stages of my design, of how this is actually going to operate in the real world and be able to get our products out faster at a higher quality. Now, I do have just 2 more slides to talk about some of the requirements here. As I did mention, this does require a special NVIDIA graphics card, so that CUDA graphics card is a requirement to be able to run this. So there are a few examples of different workstations that might have that supported, but basically that's the only hardware requirement to be able to use this extension. And in terms of our roadmap here, so coming up in December, we're going to be entering our the beta for this. So this is a focus beta in December of 2018, so coming up very soon. There's a few ways to get into this. I'm sure one of the sales reps on the line here can help you if you're interested in getting signed up for that and you want to be able to get your hands on this. But basically the objective is to be able to get feedback from users that might be testing this Creo simulation live and to prepare for our production release. And it's going to be released on 3 different versions of Creo. So Creo 4, Creo 5, and Creo 6. Those are going to be at different time frames early next year, but depending on which version you're on, it's probably going to be supported as long as you're post Creo 4. And that is all I have for Creo Simulation Live. Alex, I don't know if you want to open it up to questions or if we can take any written questions.
Yeah, we do have a couple questions, and Nelson has been brought on. So the first question is this only support parts or assemblies that are under the contract?
I'm sorry, what was that question?
Are the support parts or assemblies also under the contract, or is it just only support parts?
Hey, can you guys hear me?
Yes.
Yes, we can hear you.
All right. Hey, thanks for submitting that question. This is Nelson with PTC. So a common question we get is, can Creo Simulation Live handle assemblies as well? And the answer is yes, with some caveats, since this is linear only in the first release for structure, thermal, and modal. There are no contact regions with nonlinear capabilities. So assemblies are treated like bonded connections. We do have some examples that fits really well with, but the short answer is yes, it does work on assemblies with some caveats. Thanks for submitting that question. If you have further questions or would like additional detail, we'd love to take that as well while we have time here on this call.
Yeah, so we have a follow-up question. Can the setup model with loads and constraints be used in regular Creo Simulate, or would you have to like remodel it again?
It definitely can be reused back and forth. There are some additional analyses that you may want to run with Creo Simulate that you can't do in Creo Simulation Live. So all the good news is that all the loads, constraints, material assignments, etc. in the model, they're literally in the Creo model. There's no extra files being created here, which is a beautiful thing. They are interchangeable between Creo Simulate and Creo Simulation Live. And they could also be output or exported or sent out to additional analysis tools like Creo's had the ability to do for a long time, like out to ANSYS, AIM, or some of the other ANSYS tools, as an example.
Excellent. And then we have several more questions. So how does the analysis results compare with similar analysis run either Creo Simulate or ANSYS? Are they the same? What's basically the benchmarking comparing the end results?
So they are very close. They may not be exactly the same in all situations. There is a trade-off here in the upfront early stages where the primary most important need is flexibility and speed, but they are 80-90% the same, but you don't have to spend time waiting for the analysis to run like you would in other cases. So it's very good. The whole purpose of this, remember, is to provide early stage directional feedback as you're beginning a design and engineering things, which you can start this at very early stages so that it gets you going in the right direction, so that you're navigating, you're starting off and going in the right direction. It may still be necessary, most likely will be, to run a final validation simulation with some of your either in-house or outsourced simulation validation tools for high fidelity, high quality results that do require further expertise and setup and some other things. But remember, Creo Simulation Live is designed for the upfront early stages as you're beginning to engineer or design something to provide you that early feedback and get you going in the right direction.
So for example, is there convergence information so you know that the stresses are accurate?
There is not convergence information, and that's something that is available, in Creo Simulate. That's kind of the purpose of it, what it's been doing for the past 20, 25 years. But that is not the way that Creo Simulation Live runs using the ANSYS technology.
Okay. And then is there anything currently that show examples of how this would work with the DEX extension, the design exploration?
Yeah, so the Creo Design Exploration extension, which has been out for a few releases now, is a great way of taking snapshots of a design and making it real easy to revert back or look back at different iterations or branches of a design that you may have been researching or investigating. So a great combination would be, let's capture a couple of snapshots of the design that we've had Creo Simulation Live running on, and you can use them in combination. PTC right now is in the process of kind of documenting a few examples of that. They'll be released pretty soon. I don't know what the exact status of those are, but that is something that we are putting together some examples, because that's a fantastic high value combination when you can use real-time simulation like this and checkpoints of different design iterations that you capture with design exploration extension. So it's coming soon, but yes, the short answer is yes.
Okay, excellent. And then a couple more here. Do you know if there's also going to be plans to have CFD capabilities along with that one, the EX?
Yes, there will. And so in addition to what capabilities for simulation we have in the first release, structural, thermal, and modal, shortly thereafter, probably just a few months later, there will be additional capabilities added for fluid flow simulation.
And then are all the results of that simulation just shown during the session, or can they be stored and saved?
Yeah, so the simulation results, if you want to store and save those for someone else who may not be running Creo or Creo Simulation Live, there is basically one button click that you can push while you're in Creo Simulation Live. It'll output all the results, values, tables, screenshots, and everything out to an HTML file, which you can email to someone or store off if you want to, like at this particular point, what were the results, and share that with other people or refer to them later. You just click one button and it puts that report, outputs that report for you. It's actually super, super simple. Does a great job of capturing everything at that particular snapshot in time. Just click the report button and it pops out that HTML. Yep.
Great. Okay. And then a couple more technical questions here. Is it possible to tweak the mesh that is being used during the simulation, as well as, like, say, the shock and the analysis, like before and after?
There is no mesh tweaking, so the answer to that is no. You do not. You kind of think of it as a meshless environment because you do not refine or review or anything the mesh in the model, which is for people that have been looking at simulation software for a long time. That's a pretty new idea. That's in the past you kind of had to do that and you had to spend time doing that. You don't here in Creo Simulation Live. I'm not sure I understand the full question about shock. What the rest of that question is, but I don't know if someone else, Andrew or anybody else, has heard that question before. It does not do like what typically we see for shock tests or drop tests or other things, which are higher end kind of nonlinear simulations. I don't think there will be examples of that with Creo Simulation Live.
Okay. And is there live animations inside the model analysis?
There are animations for things like deflection and deformation or heat across the 3D model. Those types of things are available in Creo Simulation Live. Absolutely, it's part of the results.
Okay. And yeah, so it's a vibration with the shock is what he meant. So we did have several questions on the GPU requirements. I don't know if you can pull that slide up, Andrew.
Mm-hmm.
Yes.
Yeah, the basic, as Andrew cycles back there, the basic thing to remember is that it does have to be an NVIDIA graphics card. And when it comes to the GPU market, they are the only dominant player there. They have like 70%. When you get into simulation analysis, it's even more than that. So NVIDIA, number one. The biggest thing to remember, that we suggest is look at the type of NVIDIA graphics card it is. The Quadro cards, and there's a lot of them available in that family, are highly recommended. They run this very, very easily. You'll notice the second line there, minimum 4 gig of RAM. That's video RAM, 8 gig recommended for minimum. We've seen some other graphics cards, NVIDIA graphics cards, they may not necessarily Quadro, that can run this, but a lot of these have already been supported and tested and are well supported today. We're adding to this list.
Excellent.
There will be that supported systems right there. That's like for Creo specifically, but you'll notice up at the top there says PTC will offer a hardware utility. That'll be on our website. That way you just click on that, it checks your system and comes back with a little report that says, here's what we found and whether or not it's feasible and valid to run Creo Simulation Live on your hardware. So that'll make it easy.
And just to add to that, we are offering a hardware bundle that includes Creo Design Essentials and Creo Simulate. And it comes with a Dell Precision 5220 workstation, which does meet the requirements to just run it right out of the box. And it looks like the last question is just about pricing.
Yep. How much is it? The early adopter special, I know there's a link in this webcast. I noticed.
Yes, I included a spreadsheet with a link where you can just contact us with that percentage off.
So there's an early adopter price. Since this is just newly being released, we're just starting to demonstrate it. The early adopter allows you to get in early at a highly discounted price. It's $12.50 through the end of December. That will probably be about, it's going to be 2 to 4 times that when the commercial release comes out in the February timeframe. So if you're thinking about adding some of this now, you can get it at that early adopter price. That's an annual subscription price.
Great. And then finally, it looks like, what are the advantages of this extension versus just ANSYS Discovery Live?
Yeah, so ANSYS Discovery Live has only been out for a short time, and it does have a real-time simulation capability. And so from a real-time perspective, it's fantastic, and that's what PTC thought of it, and that's why we partnered with ANSYS in the first place. But the biggest reason why very few companies have actually adopted that is that as soon as you start making changes in ANSYS Discovery Live, you're doing those outside of your original CAD system, Creo, for example. So anything that you do change, the next question is, okay, how do I incorporate those changes that I've been making back into my actual CAD model, which is the system of record of what I'm going to be making? And the answer is, well, you got to redo everything, redo it all, or do it over. So the perfect combination would be, hey, if I could use that ANSYS Discovery Live capability for real-time simulation, but I didn't ever have to leave Creo. That's what Creo Simulation Live is. It's the best of both worlds.
Excellent.
And ANSYS Discovery Live still, it's still going to be around. It's still going to be available. It works with other CAD formats, but it's outside of any source CAD system. So that's the trade-off.
So this is just a fully integrated solution.
Completely embedded in Creo. Never leave the Creo interface. Yep.
Any further questions? All right, it looks like that may be it. For everyone that attended, thank you. And Andrew and Nelson, thank you again. Just a reminder, a replay will be sent to everyone, as well as just more information about the early adopter program, how to register for the beta program. And again, that's 50% off till the end of the year. So if you have any questions, just feel free to contact us. And thank you, everyone. Enjoy the rest of your week.
Thanks, Alex.
Thank you.